We have previously learned how to name ionic compounds and deduce their formula from the ionic charges. For all the ions in the examples provided, they have one thing in common. They are made of one atom and are therefore known as monatomic ions. In this lesson, we will learn how to name and deduce the formula of ionic compounds made from polyatomic ions. These polyatomic ions are ions made of more than one atom. Remember that mono means one and poly means many. Some common polyatomic ions include hydroxide, sulfate, nitrate, phosphate, carbonate, and ammonium. Note that with the exception of the ammonium ion, all of the listed polyatomic ions are anions. You will have to remember the formula and the charges of these polyatomic ions. Let's grab a piece of paper and a pencil and work on the first example. Write the sodium ion and the nitrate ion side by side. Remember to include their charges. Let's crisscross these charges. Since we never put 1 in a formula, the formula for the ionic compound in question is NaNO3. When naming ionic compounds made from polyatomic ions, we just write their names as they are. The name, therefore, is sodium nitrate. Now, for our second example, let's write a magnesium ion and a hydroxide ion side by side. Let's crisscross these charges. The structure of the hydroxide ion is not changed when forming an ionic compound. For this example, we simply need 2 hydroxide ions to fully balance out the +2 charge of the magnesium ion. This is represented by placing the O and H in round brackets and the 2 as a subscript. So the formula is MgOH in brackets 2, and its name is magnesium hydroxide. Let's say we did not put the OH in brackets. We would get MgOH2. This would mean that for each magnesium ion, there is 1 oxygen atom and 2 hydrogen atoms, which is incorrect. Are you ready to try this on your own now? Find the formula and name the ionic compound formed from potassium and sulfate ions. Please pause the lesson to try this and resume when you are done. The formula is K2SO4 and the name is potassium sulfate. We know that ionic compounds have an overall neutral charge, so it makes sense to have 2 potassium ions to fully balance the -2 charge of the sulfate ion. Transition metals are multivalent. This means that they can form ion with many different charges. For example, these copper ions can have either a +1 or +2 charge. If we form an ionic compound from copper 2+ ions and chloride ions, we must specify the valency of the copper ion in its name. So for CuCl2, the name is copper 2 chloride. Note that the valency is written as Roman numerals in round brackets right after the transition metal.